Hello, so this video will explain about the mechanism of Friedel acylation of benzene. So before we go through to the mechanism, I give the overview of what is the Friedel acylation of the benzene. It's when benzene react with the acid chloride with the presence of Lewis acid AlCl3. So what will happen, as we know that benzene will occur electrophilic substitution reaction. So we will substitute one H by electrophile. So in this case, our electrophile is this part where the CCl bond will occur bond breaking. The Cl is more electronegative. So C will become electrophile. So this part is our electrophile. So the H will be substituted with the C double bond O that attached to the alkyl group, that attached to R. So like this one, so this one is our product plus side product, 1H from the benzene and Cl from the acid chloride. Okay, so usually Friedel acylation always use acid chloride, C double bond O Cl, that attached to any alkyl group. Okay, same like Friedel acylation, halogenation of the benzene and nitration of the benzene. The mechanism of Friedel acylation also have 3 steps. Step number 1, formation of the electrophile. Step number 2, formation of the arenium ion. Step number 3, loss of H+. Same like before this, when we say formation of the electrophile in step number 1, they only involve the reagent and also the catalyst. It doesn't involve the benzene yet in step number 1. So in step number 1, to produce the formation of the electrophile, we only take this reagent, acid chloride and AlCl3. Okay, same like Friedel acylation or halogenation, the Cl is more electronegative. The Cl, which is more electronegative or nucleophile. So one lone pair from the Cl will attack the Al. As we know that Al is Lewis acid, they're able to accept electrons. So when one lone pair attack Al, so we will form a bond. So form bond between Cl and Al. So as usual, when Cl have 3 lone pair, when one lone pair already attack Al, so Cl only remain 2 lone pair because another one lone pair already form a bond with the Al. So as usual, calculate the formal charge Cl. So Cl will become positive and the Al negative formal charge. Don't forget about the charge. Okay, now this CCl bond, this one is a complex. Okay, this one is a complex. So this CCl bond is stable to be broken. So it's stable to be break. So both electron from this CCl bond will goes to the Cl. So as you want to know, C double bond O, C double bond O is very stable. So they can form resonance structure. So what will happen? One lone pair from the O will donate the electron to C double bond O to become triple bond O. So what structure you will get? R C triple bond O plus. Why the O become plus? We calculate the formal charge. So the O 6 valence electron minus 3 bond minus 2 unpaired electrons. So positive 1 charge. So the C doesn't have charge because now they already have 4 bonds. So 4 valence electron minus 4 bond is 0 formal charge. So as we know that C triple bond are stable to each other. So they will occur resonance structure. So both one electron from this one bond from this triple bond, which is 2 electron. One bond from this triple bond, which have 2 electron, will donate the electron to O. Means that 2 electron from one bond are donated to O, so they will become RC plus double bond O. So from one lone pair from the O, now they already gain another 2 electron from this one bond, so they will form 2 lone pair. So the O doesn't have charge anymore. They have 0 formal charge because if you calculate the formal charge, they have 0 formal charge. Now C have 3 bond. So if we calculate the formal charge for C, 4 valence electron minus 3 bonds, so positive 1. So this one, they are resonant to each other. So we call this one acylum ion. So when you do Friedel acylation of benzene, the mechanism, don't forget the acylum ion, they have resonance structure. They have 2 resonance structure. Okay, and then what happened to this part? They will produce AlCl4 minus. As usual, like we produce in Friedel acylation, we produce in the halogenation of the benzene. Okay, as we produce the acylum ion, the C triple bond O is more stable compared to the C double bond O. Means that in step number 2, we will bring this electrophile C triple bond O to be attacked by the nucleophile. Okay. So in step number 2, which is formation of the arenium ion, as usual, the benzene, which is nucleophile, will attack the electrophile that we produce in step number 1. So in step number 1, I know that we produce 2 electrophile, the acylation ion, C triple bond O or C double bond O. But we doesn't bring this both resonance structure to the step number 2. We only take the C triple bond O, which is more stable compared to the C double bond O. So we only bring this structure to the step number 2. So although the O is positive charge, although we can see from here when the O is positive charge, we can see that there are electrophile. But as we know that the benzene is nucleophile, so we can use any pi bond to attack our electrophile, but they will not attack O, they will attack C. So the one pi bond, doesn't matter which pi bond, will attack C, not O. Although the O is positive charge, they will attack C, and then what happened to this bond, this triple bond? One bond from this triple bond will give the electron to O. So one bond from this triple bond will give the electron to O. So what product that we produce? So as we know that when one double bond or one pi bond attacks C, so one carbon will accept the C. So what happen? They will accept C, and then C will bring the R, and then this triple bond will break, become double bond O. So if we want to show the lone pair, so from one lone pair they have, so now they already have 2 lone pair. If you want to show the lone pair, so now in this structure they have 2 lone pair. Okay, so the triple bond already broken, become double bond, because one electron from this triple bond already goes to O to make the C become stable back, which is 4 bond. Then as usual, when one carbon already accept the electrophile, another carbon will become positively charged, because they already have 1 H, and if you calculate the formal charge, 4 valence electron from C minus 3 bond. 1, 2, and then another 1 electron with the H. So they become positive charge. So as you know that the benzene have unusual stability. So they will help each other to stabilize the structure. So as we know that same like what we do in the halogenation of the benzene and also in the nitration of the benzene. So these 2 electron from this pi bond will donate the electron. We donate the electron to the C plus bond, and then they form double bond here. This double bond still maintain, and then this C will become positive charge because they have less of 1 bond. And then same goes to stabilize the structure. This double bond will give the 2 electron to this side, to this C single bond C, and then they will move the double bond from here to the here. And then this carbon will become positive charge because they have less of 1 bond. Okay, so the same goes. So remember, this one arenium ion. This one is arenium ion. You must show all these 3 structure with the arrow. Don't forget about the arrow. And step number 3 is loss of the H plus as usual, because we already gain our electrophile. So we need to lose the H. We need to lose the H plus on the carbon that we already gained the electrophile. We will not lose the H plus from the other carbon, but we will lose the H plus from the carbon that we already accept the electrophile. So in this case, I will take this structure. It doesn't matter which structure you take in the step number 3. So now I take this structure to the step number 3. So I want to lose this H plus. So as usual, we must use the AlCl4 minus that we produce in step number 1, because we need to produce back our catalyst AlCl3. So what happened? One lone pair from the Cl attack H, and then this bond will goes to the C single bond C to form double bond, and then we need to break this Cl-Al bond to form our catalyst back. So both electrons goes to the Cl. So they will produce benzene that attach to the C double bond OR, and then plus with the HCl, so this part HCl, and then AlCl3. So this one is the mechanism of Friedel acylation of the benzene. So we can see that mechanism of nitration of the benzene, mechanism of halogenation of the benzene, Friedel acylation of the benzene, and also Friedel acylation of the benzene. Step number 2 and step number 3 are almost same. Always produce the arenium ion and then they lose H plus by using the catalyst that we produce in the step number 1. The only difference in the these 4 mechanisms, nitration of the benzene, halogenation of the benzene, Friedel acylation of the benzene, and Friedel acylation of the benzene is step number 1. So remember that in the benzene mechanism, the only difference in the mechanism is only on the step number 1, how we produce the electrophile, how we produce the NO2 in nitration of the benzene, how we produce the complex in the halogenation of the benzene, how we produce arcylium ion in the Friedel acylation, and how we produce carboxyl ion in the Friedel acylation of the benzene. So I hope you already understand the 4 mechanisms of the benzene: nitration of the benzene, halogenation of the benzene, Friedel acylation of the benzene, and Friedel acylation of the benzene. Okay, that's all for mechanism of the benzene. Thank you.